Okay, students, today we're going to talk about simplifying a radical fraction. And what we don't like to see are these radicals in the bottom of the fraction. That indicates that they're not in simplest terms, which is not what we like. In order to get it in simplest terms, we want to get that radical out of there, which may seem like a difficult task, but we have a method to the madness in order to attack this, and we're going to multiply by what we call the conjugate. The conjugate is actually the same term as what's on the bottom, however it has the opposite sign. Okay? So instead of the square root of 5a plus 3a, we're going to do the square root of 5a minus 3a. And whatever we multiply the bottom by, we have to multiply the top by. That's one of our cardinal rules of algebra. What you do to the bottom, you must do to the top. And that is because if I multiply the top and the bottom by that value, essentially I'm multiplying by 1, because anything divided by itself is the number 1. So that allows me to do that because I can multiply anything by 1 and technically not change my values. Now this is going to require a fair amount of algebra and a fair amount of multiplying, so we're going to tackle it one piece at a time, which I think is often easier than looking at it as a whole. We're going to look at the top first, and just kind of ignore the bottom right now. We'll get there. And so we're going to multiply a cubed plus 2a times the square root of 5a minus 3a. And this involves doing some foiling because we have a binomial times a binomial. And remember that when we have a binomial times a binomial, we get to use our little FOIL trick to help us remember. So we're going to start by doing our first term times our first term, which is going to be a cubed square root 5a. Our outer term times our outer term, that's the O in FOIL. Outer times outer. And remember, when we multiply, we do add exponents. And I don't see an exponent with the a, so it is really a 1. And then we're going to do our inner term times our inner term. And finally, to round this out, we're going to look at our last term times our last term. And the same goes here. We are going to add those exponents, and remember to multiply the numbers out in front. Now that's a lot of algebra going on, but I do notice that each term does have something in common, and it has in common the letter A. So what I'm going to do is I'm going to take an A out because I think that's going to help me simplify in the end. So I'm going to take an A out, which leaves me with a squared square root 5a minus 3a to the third plus 2 square root 5a minus 6a. Now, unfortunately, although it would be really nice if we had some like terms going on here that we could combine to make this look a little happier, nothing is actually alike. They've all got different exponent combinations on them, so we actually just have to leave it as one giant problem there. Okay, let's take a look at the bottom, and then we're going to put it all together. And you'll see why we like the conjugate as we multiply out the bottom. Okay, so let's take a stab at multiplying the bottom using our FOIL method. First times first, and remember, a root times a root, a square root times a square root makes the root go away, so we just have 5a. And then we're going to look at our outer times outer. Negative 3a root 5a. And then our inner times our inner. And this is going to be positive 3a root 5a. And then we'll look at our last times our last. And that's going to be negative 9a squared. And remember, a negative times a negative is a positive. Now let's look at why we like this method. Because what's going to happen is in the middle we have a negative 3a root 5a and a positive. They are exactly the same, which means they cancel out. It's opposite signs, but we have the same exact like terms. So now I'm left with 5a minus 9a squared. And if I take the letter a out, because they both do have an a in common, I'm left with 5 minus 9a. Now we get to put it all together. So we're going to put our top on top, denominator on top. And it's a lot of letters going on there, and I know it's hard to keep all those letters straight. And then on the bottom, we have our a, 5 minus 9a. And those a's are going to cancel out. That's why that was my hope and my intent when I factored it out, that was eventually that they were going to cancel out, and I would be left with my final solution of a squared square root 5a minus 3a cubed plus 2 square root 5a minus 6a. And I will often have students ask me, well, couldn't I factor an a out of there? And the answer is technically you could factor half an a out, because the square root of 5a would be a to the 1/2. But I wouldn't really bother, because there's no a's left on the bottom to cancel it with, that it's not really going to get you anywhere, that it's actually going to be easier for you just to leave it as one giant long term. And there is no real standard form. If you want to try and put it in descending order, you can. And that would be the negative 3a cubed plus a squared root 5a minus 6a plus 2 root 5a. However, you don't have to do that. That's not something I'm going to pick on you about, because that does actually give us a negative leading coefficient, which then technically we should deal with. But we're going to leave it as that and say that if you want to reorder it, you can, but if you also want to leave it as the previous form, that's going to be okay for you too. So hopefully that's going to help you out with rationalizing a denominator that has a root in the bottom. If you have questions or concerns about any of the numbers or where they came from, just shoot me an email and let me know. Have a great day.